Hi everyone, I'm Christina and welcome to video 16 in our A-Level Mathematics Calculus series. This is Differentiating Composite Functions Part 3, and our objectives are to apply the chain rule to composite trigonometric functions. So in our first example, we want to find dy over dx for y equals sine of 3x squared. So here we have our composite trigonometric function. So first, let's recall the chain rule. So dy over dx is equal to dy over du times du over dx. So in this example, let's let u equal 3x squared. So u is our function within our sine function. And we can see it's 3x squared, so it's in terms of x, which is what we want. So if we have u as equal to 3x squared, we can rewrite y as being equal to sine of u. Okay, so that comes from our original function there, and substituting in u equals 3x squared. So now we can try and find dy over du. So let's differentiate this with respect to u. Well, when we differentiate sine u with respect to u, we get cos of u. So now we have our dy over du, which we're going to use when we apply the chain rule. And now we want to find du over dx. So if u is 3x squared, du over dx, well, we're just going to use our knowledge of differentiating powers of x. So we're bringing down the power, multiplying it by the coefficient, and then taking away 1 from the exponent. So then we get 6x. Yep. So now we can substitute these into our formula for the chain rule, and we can say dy over dx is equal to dy over du, that's cos of u, times du over dx, that's 6x. But we want our differential of our function here to be all in terms of x. We have x here, but then we have u here. So our final step will be to substitute u equals 3x squared into cos of u. So our final answer will look like this. Dy over dx equals cos of 3x squared times 6x. And we typically write that as 6x cos of 3u of 3x squared. And that's all in the cos function. And so that's our final answer. Okay. So for example 2, we want to differentiate the function f of x is equal to 3x to the power of 7 minus sine of x squared plus 6. So the first term here is not a composite function. That's quite easy to differentiate because, again, we're just using our differentiating powers of x knowledge. So this actually, if we differentiate 3x to the power of 7, that just gives us 7 times 3, that's 21, x to the power of 7 minus 1, that's 21x to the power of 6. So we want to look at this term here, our minus sine of x squared plus 6. So let's let y equals sine of x squared plus 6, and let's focus on differentiating this and then substituting it back in, so we get our full differentiated function of f of x. So if y equals sine of x squared plus 6, we can see that this is a composite trigonometric function, and let's let u equal x squared plus 6. Let's recall the chain rule quickly. So our chain rule is dy over dx equals dy over du times du over dx. If u is x squared plus 6, we can rewrite y as sine of u, similar to the example before. And so when we differentiate with respect to u, we just get cos of u. And we also need to differentiate u with respect to x. Now, if u is x squared plus 6, then we can simply differentiate u with respect to x, and it will be equal to 2x. Okay? And so now we can substitute these into the formula for our chain rule. And so dy over dx is equal to dy over du cos of u times 2x. So write that as 2x cos of u. But again, we want it all in terms of x. So we want to substitute in u equals x squared plus 6. So that's equal to 2x times cos of x squared plus 6. And so now we've differentiated our second term up here. And so overall, f dash of x, so that's our differential for the entire function f of x, is going to be equal to 21x to the power of 6 minus, let's not forget the minus sign there, the differential of sine of x squared plus 6, which we just found here. So it's going to be minus 2x cos of x squared plus 6. And that is our final answer.